Hello, everyone. Welcome to my channel. And today we'll be studying a very important concept, which is graphs of functions. Now, whenever it comes to this topic, there are two different aspects, I would say. One are those structured questions that you would probably see in paper two, where they would expect you to fill out the table, plot the graph, figure out, the intersection, or you have to manipulate using the algebraic expressions. Now, that's not something I'm going to be discussing in this lesson. In this lesson, I'm just going to be mainly going over the concept which requires you to recognize or sketch the graph. Now, I must remind you, this is again something that has been recently added. So if you're practicing for this concept, you may not be able to see any question related to sketching in O-level mathematics exam. Obviously, you'll be able to find this in IGCSE because it has been there for a while. I've already uploaded a worksheet if you want to practice. And again, we'll be discussing the same worksheet over here as well. So let's continue. Now, whenever it comes to identifying or even sketching as well, the first type of graph that we have is known as a linear graph. Now, whenever I say the word linear, that means it's a straight line. So if I were to sketch this out, maybe I can say this is the kind of graph that I have. And the equation over here says sketch y equals x plus 2. When the word sketch shows up, I want you to understand that mainly they're interested in identifying or in you identifying the x-intercept and similarly the y-intercept. So any question that is asking you to sketch would probably require this. Yes, they might require you to find the asymptote as well, but that's going to be, again, stated in the question if that's what they want. Now, in this question over here, I know that if I want to sketch something out, the easiest way, so there are multiple ways in which you can do that. The safest, however, is always by plugging in x as 0 and similarly y as 0. So let's try this out. Now, in this case, if I were to plug in x as 0, that's going to give me y equals to 2. In a similar way, if I plug in y equals 0, this should give me x equals to minus 2. I've just moved this on the side. Now, so I have two bunch of points. So I can say, this is going to be minus 2 comma 0. And similarly, this is going to be 0 comma 2. Let's kind of plot this over here. So I know 0 comma 2 should be somewhere over here. In a similar way, minus 2 comma 0 is going to be over here. I would expect that you label this out on the axis. So 0 comma 2, and that's about it. You take your ruler and you draw a straight line over here. Now, again, you might ask, why do we need to use a straight line? Because like I said earlier, it's a linear graph. So that's how we draw this, and there is nothing more that we have to label out. I usually get this question, is it usually better if we label out this line as y equals to x plus 2? You can. I think that's just going to look nice, but otherwise it's not a requirement. In a very similar way, the second type of concept or second type of graph that we have is known as the quadratic graphs over here. Now, quadratics are generally of different kind, and I would expect that you should know what's the general form of a quadratic equation. So when I say any quadratic equation, that means ax squared plus bx plus c, and obviously that's how you express some sort of value, which is y. Could be f of x as well. Now, a actually determines a lot of things. So the idea is that if a value is greater than 0, then the graph has to be a U-shaped graph. In a similar way, if a value is less than 0, that means a value is negative. It's going to be an inverted U-shape or inverted parabola. And the C over here is what represents the y-intercept. So there's a lot of stuff that we can actually identify just by looking at the question. Now, let's say I give you a question. Let's say I'm asking you, please sketch y equals to x squared minus 5x plus 6. Now, you see, when it comes to these kind of questions, what did I say about sketching? What does it require you to figure out? Can I say they're asking us to, again, identify the x and the y-intercept? That means if I were to make a scale over here, and this is going to be my x-axis, and this right here is my y-axis. Now, again, this question requires us to figure out the x and the y-intercept. So in this case, I can easily see that it crosses through positive 6 on the y-axis. So at least I'm familiar with my x-intercept. And if you want to show this as a working, which is something I would recommend on your side, so I would say that you plug in x as 0. If I did, that's just going to give me y equals to 0 squared minus 5 times 0 plus 6, which leads you to y is equal to 6. That means we have the y-intercept that is 0, 6. But now comes the real challenge, which is to figure out the x-intercept. And the x-intercept is something that we figure out using quadratic formula. If you remember that factorization, how do we solve a quadratic equation? By either using the midterm breaking or using the completing the square. And the third one is, of course, by factorization or midterm breaking, I could say. I think I've already said it, so the formula has to be the third one. Anyways, whatever it is, you can easily figure this out. So let's start factorization. I think in this case, to me, what's easier is perhaps the midterm breaking. So I can say, well, x squared minus 3x minus 2x plus 6. I take x common out, that's going to give me x minus 3. The same thing over here. That means I'm going to be left with x minus 2 and then x minus 3. And that represents me y. And like I said earlier as well, the best way to identify these intercepts is by plugging in x as 0 and similarly y as 0. So if I plug in y-intercept or y value as 0, can I say x value comes out to be 2? In a similar way, the second x value that we'll be having is 3. So I can say, if I were to label this out, this is 2, and this right here is going to be 3. In a similar way, the y-intercept, which is going to be 6 on this side. Let me just make this a little, okay, now it looks better. Now the question expects us to obviously sketch it. Now, just by judging a value, I can see that my a value is positive. That means it's going to be an open shape, a concave up, I should say, parabola. So I can easily draw this out. And you can see that's how the graph looks like. I would expect, again, when you're drawing this out and this question shows up in the exam, this is probably going to be worth a minimum of 2 or a maximum of 4. And they would require you to identify these x and y intercepts. I get this question, aren't we supposed to figure out the minimum point, which is going to be this? Again, you can, using completing the square, you can figure out the vertex. We call this the minimum point as my vertex in this case. You can figure this out, but that's not what the question says. So in some questions, they're going to explicitly mention, also figure out the minimum point. Usually, if you ask me, I think the first part is going to ask you to solve a question based on completing the square. And the second part is going to ask you to sketch it. That automatically means that if you already have those points, you can easily plot it. So that's how it works. I hope this concept is clear. Again, we'll do some practice questions, and trust me, this is going to further develop. In a similar way, we also have a cubic graph as well. Again, it has to be done exactly in a very similar way. I'm just going to quickly introduce how the graph looks like. So there's not much that you have to do. What you need to realize over here is that there are two types of cubic equations. One which we just have a value. So for those of you who have been in my class, let's say if we have y equals to x cubed. Now, I did mention that if it's a positive x cubed, that means if I were to sketch this, the graph is going to start from this positive side and go like this. In a similar way, if y equals to minus x cubed, again, the graph is going to start from the negative side and go into the positive side. That's how it goes. But what if the question has something more to it? What if we have x cubed plus 2? That means now my graph has been shifted 2 units up. And they would expect that you label out this point as 2. That's it. In a similar way, what if this was minus x cubed minus 3? That means, again, they would expect that you label out the y-intercept. I get this question. Aren't we supposed to label out this? Not really. You can see, you can try this out. So again, how did we figure out this? I said, you plug in x value as 0. So in this case, I said, well, if x value is equal to 0, that means this equation becomes y equals minus 0 cubed minus 3, which is minus 3. Easy. But in a very similar way, if I plug in y as 0, now that's going to be 0 equals to minus x cubed minus 3. So that's going to be x cubed and then minus 3. And you can see that if I took the cube root, it's going to be x equals to cube root of minus 3. Now, the question that I get is, clearly this has to be a math error. Wrong. Cube root of a negative number is possible, but not the square root. So keep that in mind when you're solving these kind of questions. Yes, this can be done in the calculator. And if I were to solve this, this probably comes out to be 1.44. So, I mean, this point is not something that I've done accurately, but if I did, wait a second, this was, my bad, minus 1.44. So this has to be minus 1.44. Again, they don't expect you to plot this. And even if they did, you can just leave your answer in this way. Cube root of minus 3. That is it. I would expect that you leave your answer in this way. Again, it's highly unlikely that you would get a question like this. But if you did, you should know that's the way out. Now, having said this, we're going to move on to the next topic, which is, I'm going in an order over here. So far we have done linear, so far we have done quadratic, now we are on to reciprocal. When I talk about reciprocal, again, this kind of graph is, again, highly likely to ask you to figure out the x and the y-intercept. So the question would specify that they would probably expect you to find, I don't know, the line of symmetry or something like that. So let's say we have y equals to 1 over x. Now, in this kind of question, I can say that this is how the graph looks like. And again, this is where we have our asymptotes on the x and the y axis. So maybe they might ask you, list down, or identify the asymptotes. That's one of the kind of questions that you could expect. Or another question might be, identify the line of symmetry. So I can say that's the line of symmetry over here. This over here will be my line of symmetry. I believe there's a question that came in way back in 2005, which is quite similar. So they've given the sketch and they're asking us to figure out the line of symmetry. So again, these kind of questions, they don't have any x or y intercept. So it's not possible for us to figure out x and y intercept. If it's not possible, that means it doesn't exist. So we don't need to do that. And finally, the last kind of question that is based on an exponential graph. Now, again, an exponential graph is very important. For an exponential graph, they would expect that you label out the x-intercept and the y-intercept. And especially when I talk about x-intercept, only if it's possible. So let's say we have a question where I'm asking you, please sketch y is equal to 2 raised to the power x. So when you see this kind of question, what does that show you? This clearly shows us that x equals to 0. I can say that's going to be y equals to 2 raised to the power 0. That's 1. So my coordinate would come out to be 0, 1, which is probably going to be over here. Again, I get this question, are we supposed to list down the whole coordinate, or is just labeling out the y-axis enough? Just labeling the y-axis, not the whole coordinate. I mean, you can do it either way, but you don't have to. And then, if you were to plug in y as 0, you'll see that that's not possible. 0 is equal to 2 raised to the power x. That does not exist. That means in this kind of question, we do not have an x-intercept. No x-intercept. If the x-intercept doesn't exist, that means we're not supposed to plot. In a very similar way, I know that if I were to sketch this graph out, this is how it's going to look. That's it. That's all you have to sketch. I hope everyone, the concept is clear. Now let's dive into the past papers. So I'm going to come back to question number 1 in a while, but let's have a look at question number 3. Now, again, question number 3 is a cubic equation. And how do I know? Well, if you don't believe me, you can multiply all these 3 values and you will realize that this come out to be a cubic equation. But you have to be very careful as to which kind of cubic equation it is. So let's read the question. It says, sketch the graph of this, blah, 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 indicating the coordinates of the points where the graph crosses the x-axis and the y-axis. So they've explicitly mentioned that they want you to figure out the x and the y-intercept. If that is the case, you can see that if I multiply this x with this minus x and with this x, so I'm multiplying x with minus x and then x. Can't you say that's going to be a minus x cube graph? And so far, what's the concept that I've taught you about minus x cube? That the graph has to start from the left side. That's how it's going to be. Again, there has to be some sort of double bend or some sort of bump. So ideally, when the question has x cube plus x, blah, blah, blah. So it's not just x cube. If it was just x cube, we would have drawn it this way. But since the equation says something more, that's the reason why it's going to have a little bend. And I will show it to you how that's possible. So in this question over here, I'm just going to first figure out x value is 0. So let's identify if my x value is 0. X value as 0. So can I say this equation would be 0 plus 1. Similarly, 3 minus 0, that's just going to be 3. And finally, 3 plus 0, that's also going to be 3. That means my coordinate on the y-axis come out to be 0, 9. In a very similar way, now I'll plug in y as 0. If I did plug in y as 0, that's going to be 0 equals to x plus 1, 3 minus x, and then 3 plus x. If you equate it individually, you'll realize x equals to minus 1. Then we have x equals to 3. And then we have x equals to minus 3. So let's start plotting these values. I know minus 1 is over here. Similarly, minus 3 is somewhere over here. And 3 is on this side. In a very similar way, we got 9 over here as well. Now, the question says that we have to figure out the sketching as to we need to sketch this graph out. And I've already mentioned just repeating the same thing. If it's minus x cubed, we start from this side. That means, everyone, these are my x-intercepts. So I would start from this side. And if I did, this is how the graph is going to be. I'm kind of proud of the way I've done, but hopefully, I hope you get the idea. So again, we started off with the left side, this, and boom, that's how the graph went. So I hope this concept is clear on how we can sketch a cubic equation, not just a positive x cube or negative x cube, but something that's more than that. The question that I get is, what if this was expanded? How would we factorize it? Honestly, that's beyond the scope of O levels. And I will show this to you just to prove it to you that this is not actually included. Then why are we doing it? So that you can understand the concept relatively better. And again, if something bad happens in the exam, just remember that you already have, almost everything else and you know exactly the concept. So you shouldn't be worried about it. All right. So now let's move on to the next concept or next question. It says on the diagram, sketch the graph y equals to x minus 1 whole squared. Now, there are different ways of doing it. So ideally, again, let's plug in x as 0. If I did, that's just going to give me y equals to minus 1 squared. That is going to be 1. That means the graph is going to be somewhere over here. 1 lies on that side. In a very similar way, let's plug in y value as 0. If I did, that's just going to give me 0 equals to x minus 1 squared. Now, if I were to square root on both sides, square root of 0 is 0. So 0 equals to x minus 1. And then I know that x equals to 1. Now, you should understand that this kind of question is actually based on a quadratic equation. So they're not going to tell you that it's a quadratic equation. They would expect that you should, if you're sketching it, you should know the very basics as to how it looks. I can expand it, and obviously that's going to give me x squared minus 2x plus 1. I don't have to. I'm just trying to teach you that this is a quadratic equation. What does a quadratic equation mean? That it's a U-shaped graph, right? So can I say, everyone, that the graph is going to be something like this? There you go. Again, please do not use a ruler for these kind of questions. Just try to make a better sketch. So I'm done with part A. The next part of the question says y equals half x plus 1. Again, I'm just going to repeat the same approach. Now, some teachers would tell you to do it directly. That's fine as well. Ideally, you're not supposed to show any working, but if you did, I mean, I would, just to be on the safer side. So y equals to 0 plus 1, that's just going to be 1. In a similar way, when I plug in y as 0, that's just going to give me minus 1 and then 2. So minus 2 is equal to x. So I know minus 2 lies over here. I hope I'm not going too fast. And this over here is 1. Again, you take a ruler. Why? Because now it's a linear equation. So you can see this is how the graph looks like. A question that I get is, are we supposed to make this intersect? I mean, sure. They're not asking us, so it doesn't really matter. In a similar way, this part over here. Now, this is where you might ask, wait a second. We don't know how to factorize a cubic equation. Well, actually, you do. And they would expect that you should be able to solve this. I mean, probably not in sketching graphs, but perhaps in algebra. If I ask you factorize it, how would you do it? Can't you just take out x common out? Wouldn't that just give you x squared minus 4? And can't you see that this is where you can apply the identity a squared minus b squared equals to a minus b, and then we have a plus b. That clearly tells us that this equation has to be x minus 2, x plus 2, and that's my y. So now, again, I have the same equation. I want you to pause this video and quickly try this out on your own. All right, let's hope you've done it correctly, and let's see. So again, the first task is to plug in x as 0. If I did, that's just going to give me 0, and then again minus 2, and then plus 2. Obviously, anything times 0 is just going to be 0. So I know that one of the points has to lie over here. The second is, of course, the x-intercept. And for this, I will say x equals to 0. So we already have one of those points. X equals to 2, and then x equals to minus 2. So I know 2 lies over here, and minus 2 probably lies over here. Now, again, what kind of question is this? Positive x cubed. What does that show you? That it has to start from the right side. You see how those concepts are coming in handy? Anyway, so I know that the graph has to go in this way, up, and boom. I hope the concept is now getting better, right? In a similar way, let's try another one. Again, this requires you to solve it using completing the square. So let's try this out quickly. I hope you guys are familiar with completing the square, so I'm just going to quickly solve that. All right, this is what I get. Now, again, when you look at this question, what does that tell you? If I, again, plug in x as 0, although there is a much direct way of doing this, but I'm just going to ignore that, you will realize the value come out to be 14. If you want me to prove this out, well, we can. So y equals to 5 squared minus 11. That's going to be just going to give you y as 14. So we already knew this. In a very similar way, I'm just going to plug in y value as 0. If I did, that's just going to give me 11 equals to x plus 5 whole squared. Now, you see, this is where the problem comes. And the problem is not that you don't know how to figure this out. The problem is that if this kind of question shows up in paper 1, we would only leave it in this form, square root 11 minus 5. But the question was never asking us this. You see, this is what you need to realize. Not every question is going to ask you to sketch, and they wouldn't expect you to label out the x and y, intercepts. So since the question over here explicitly says they just need the turning points, that's it. They don't need anything else. So can't you say that if that's the case over here, then that clearly means that I would actually, we can see just by looking at it that it's going to be obviously 14 on the y-axis. However, I would expect probably by this time you guys are familiar with how to identify the turning points. Anyways, in this case over here, you have to understand that the general form of completing the square is ax minus h squared plus k, where h comma k, they are going to be my turning points. So if I were to compare this equation with the one we just have, I can clearly see that my h value has to be minus 5. In a similar way, my k value has to be minus 11. So now let's plot this. Minus 5 is over here, and minus 11 is probably all the way down. This has to be my minimum point. And this was 14 was my y-intercept. So if I were to sketch this, this is how the graph looks like. If you check this out, this would probably be this point. But again, we don't calculate this because that's not what the question is asking us. So I hope the question is clear on how we solve it. In a very similar way, let's also have a look at this question as well. Now, in this case, it says y is equal to 2 raised to the power minus x. Now, this is actually very important. Why? Because if I plug in x as 0, what does that give me? Y equals to 2 raised to the power minus 0. Now, whether it's minus 0 or any raised to the power 0, that doesn't really matter, right? So what if it's minus? Anyways, in this case over here, I can clearly see that this has to be 1. That means my y coordinate is going to be 1. But now comes the real challenge. What if y is equal to 0? Well, that's not possible. We can't have 0 equals to 2 raised to the power minus x. That's not possible. Another challenge that I get is, how should we, where exactly does the graph go? So I told you earlier, if it's something 2 raised to the power x probably, it's going to go this way because it's a positive exponential growth graph. But in this case over here, the graph is actually opposite. And how do you know that? I would expect that you can just convert it. So in this case, maybe I can write down this equation as y equals to 2 raised to the power of 2 raised to the power minus x. And we can translate that as 1 over 2 raised to the power x is equal to y. So this is what we are doing. You see what's happening? It's actually in the denominator. I hope this concept is clear. Now, you can plug in anything you want. You can probably plug in 2 raised to the power, let's say x at minus 2. X at, we can even start at positive 2. Doesn't really matter. Y is equal to 2 raised to the power minus 2. Again, that's just going to be 1 over 2 squared. That's just going to be 1 over 4. That means the value is somehow getting closer. So at 2, the value is getting closer. And at 3, the value is getting more closer. So if you actually sketch this and you take multiple values, you'd realize the graph looks like this. So it's going from upwards. It's a reflection. I hope everyone, this concept is clear. Let's do one last question, then we'll probably end this. Now, the very first question of this video is perhaps worth $1 billion. The question says the graph of a cubic function has 2 turning points. Obviously, that's true. When we look at a question, how does it look? How does a cubic graph, the questions that we have done so far? Can't you say that in this case, this is a turning point, that's also a turning point? So there are 2 turning points for a cubic equation, at least the one they're talking about. When x is less than 0 and x is greater than 4, the gradient of the graph is positive. What does the word gradient as positive means? The word gradient as positive means the graph is going upwards. So at 0 and at 4, I know the graph is going upwards. That's what I know. That the line is going upwards somehow. It could be from here as well. It could be from here as well. I don't know. And similarly, it says when x is in between 0 and 4, the graph is negative. And the graph passes through the origin. That means this is going to be my x or y intercept. Now, if you're actually supposed to, if you sketch this out And we only need to sketch it out for 0 and 4. Obviously, we'll go a little beyond that as well, just to make the concept clear, but let's see. So in between 0 and 4, the graph is negative. Don't you think this line is going downwards? That means this definitely means the graph or the gradient is negative. In a similar way, after 4, the gradient becomes positive. And it also says that before 0 as well, the gradient was positive. That means before 0, the gradient was positive. So this is how the graph looks like. Now, I know I've drawn a very ugly graph, but I hope you get the idea. It's positive before 0. X is less than 0. It says X is less than 0. The gradient is positive. Similarly, after 4, it's also positive. And in between 0 and 4, it's negative. Like I said, this question is very important. And if you've understood this, that means you've probably understood the whole concept. With this, everyone, we come to an end. Let's catch up again in another video. Till then, adios.